Hi everyone, I'm back here to finish up the exploration for section 6.1, I'm sorry, section 1.6, which is on piecewise defined functions. I believe the other video got all the way through number 4a, and we mainly just want to take care of 4b here as well as 5b down below it, where we find the domain and range. So there's a couple ways to approach graphing a piecewise defined function like this. I think maybe the best way is just the most straightforward way, in that, I'm going to graph this line negative 2x minus 4, but then I want to make sure that it's only for the x values that are less than negative 2. So you might just want to just make a table here. We'll do this part in green. A little XY table. Of course, we could plug in. Even though you can see that we're not going to actually equal negative 2, we still need to know what's happening at negative 2 for this part. So I would try negative 2, maybe negative 3, negative 4, get back some values, plot some points, and see what that graph's doing. You know it's linear. You can tell its slope is negative 2, so you can deal with that as well. Even just getting 1 point, then you can use the slope. And then you can do the same thing for the middle part. I'll change my color here. We can make the middle part blue. Okay, and you can make a little table there. So I just want to maybe put that in your head to give that a try. Of course, we can do this last part over here. Maybe I'll do that as red or kind of pinkish. And make a little table XY and see what you get, and then plot your points. Okay. So there's that method. The other method is you could actually try to graph the line and then erase the parts you don't need. And I can show you that, but I want to give you a chance to try to graph this first. So why don't you pause the video, give this a shot, and then we can check what you did with what I've got. All right, see if this is what you did here. I'm going to go back to green, and if I do plug in negative 2, I'll have negative 2 times negative 2, which is positive 4, minus 4, so that's going to give me 0 at negative 2. And even though that point is not on the graph, I know my graph is going to go up to that point, right? So I might just want to put this in as a unshaded circle. And the fact that my slope is negative 2, I could use that to help me find the next point, right? We know that, let's see, now we're talking about values of x that are less than negative 2, so this would mean we could put the negative on the 1, or in other words, we could move left 1 left, and then we know we would be going up 2. So if we went 1 left, we'd go up 2, and that would put us right here at negative 3, 2. Now let's check that out. If we plug negative 3 in here, we'll have negative 2 times negative 3, which is positive 6 minus 4. Yes, that would give us 2. So there we go. We got that point, and then we can just keep this trend, and we have this part of our graph here. I'm going to see if I can draw it in. I may just have to resort to using a shape up here. Sometimes the shapes don't work great either, but let's see if we can get a line to go through our points. There we go. It's kind of hard though to get the line to do exactly what you want it to. But let me see if with my mouse I can maybe grab that piece. Is it going to let me do that? Yeah, it's not being easy, but let me move it around a little bit, see if I can fit it right where I want it to. There we go. I think that's what we're looking for. All right, so there we go. We've got that green piece of the graph. Now we can go in and do the blue piece. Now the blue piece has 2 endpoints to it, so let's definitely figure out where negative 2 would be. If I plug negative 2 in here, right, parentheses be negative 2 plus 2 is 0. Here, put this over here, so we'll have 1/3 times 0, which would give me 0 plus 1. I'm going to be getting getting back 1. If you want to write it out, it was 1/3 times 0 to 3 plus 1, so that equals 1. So I'm going to have the point -2, 1. So this point right here, and this time I will shade it, right, because we're including the -2. And then, maybe the best thing to do is just plug in the 1 and see what we get there. Even though we're not going to include the point at x equal to 1, we are going to go all the way up to that point. So if we plug in 1, we'll have 1/3 times 1 plus 2, so it's 1/3 times 3, right? Which is just going to be 1 plus 1, so I think we're going to get back 2. So we're going to go all the way up to the point 1, 2. Let me draw in a circle again. Here, I'm going to undo that and try to draw that again. So it's more in the spot, and we're basically just going to have a line that goes right there. Okay, not a great line, but give it that a try. And we can check that. We have our slope is equal to 1/3, so that would tell us, move up 1 and to the right 3, or move right 3 up 1. So there we go. All right, so there's the second piece of our graph, and now we just need to do the third piece here. And this one starts at 3. This is for x values greater than 3, so we could start at 3. And if we plug that in, it looks like we'll have -3 minus 1, which would give us -4. So we have the point 3, -4, which is down here, and we're going to include that point, right? Because we're including the 3. And then it looks like our slope here is -1. So let's see, since we have to move 1, we have to move right, because we're for x greater than 3, that would tell us that we're going to go down by 1 every time we move right 1. So right 1, down 1, right 1, down 1. And let's just check that. If we plug in +4, we'll end up with -4 minus 1, which would equal -5. So I think we're doing correctly here. And let me see if I can draw this in. I'm not very good on the ends here. This is not going to be easy to do. Here, I'm going to pause the video and get my line drawn. There we go, that worked pretty well. And let's see, I'm just going to put a little arrow here on the end of that one, and maybe go over to green, put a little arrow on the end of that one, because it continues on. All right, and I believe we have our graph, these three lines. I guess one's a segment. Now, we need to figure out the domain and range of this function. So let me switch over to a different color. Let's see, I think I'll use purple for domain. And of course, we're trying to figure out all the x values. So let's just, sweep across, ask ourselves, have we got points with x coordinates that have these values? And I think we would be saying yes, right? All the way till we get to maybe at -2. But even there, I believe we're going to be able to say yes, right? Because we do have this point up here with -2. All right, so we're continuing to say yes. All right, I'm going to stop there, and why don't you see if you can finish figuring out the domain, and then maybe also see if you can get the range. All right, pause the video and give that a try. Okay, let's check and see if what you wrote down works here. So we were saying yes is all the way here, and we can keep saying yes, I think, until we get to 1, right? That's where we get our first no. So it seems to me like we're going to have all x values less than 1. We don't want to include the 1 because we have that unshaded. Here, I need to point with my mouse. I'm forgetting. So we don't want to include the 1 because we have this unshaded part of the circle, all right? And it looks like now over here we have no's for anything greater than 1, right? Up until we get to, looks like 3, we pick back up with a yes, and we want to include that. And so we're going to have here, maybe I should just write, we're going to have yeses, yeses, yeses all the way. Okay, here we had yeses all the way here until we got to to x equal to 1, and we had no's. So I'll put some n's there. Okay, So we want to include, looks like from 3, anything greater than 3. So x is greater than 3, and I think we should equal, right? Even equal to 3 because we are including that point at 3. So here we have our two disjoint sets for, we got our values basically less than positive 1, and then we have our values greater than or equal to 3. And because we have these two disjoint sets, we want to use the conjunction or in the middle, right? So the domain is x is less than 1, or x can be greater than or equal to 3. Doesn't make any sense to say and, because there's no number that can be in both of these sets, so we have to say or. All right, going on to the range now. Hopefully you use the same kind of logic. I'm going to start down here at the bottom, and looks like we've got y values, right? Points that have these y values. So we'll go yes, 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 all the way up to -4 here, right? I think we have a yes. But after -4, I don't think we have any y values, right? So let's say y is going to be less than or equal to -4. And so now we've got no's, no, no, and I get to 0 here, and I do see that maybe I've got a y value there, but not right at 0, right? It's going to have to be after, right after 0. But after that, we've got plenty of yeses, right? Yes, 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 all the rest of the way. Even though there's no y value at this point here where I'm pointing here with my cursor, even though there's no y value there, we do have a y value of 2 all the way over here on the green part, so we can include that. All right, so we're going to have y being greater than 0 on the top end, right? And once again, we have two disjoint sets like this, so we're going to say or. If we were graphing this, we'd basically be talking about all these numbers, and then from 0 on up, we've got all these numbers right here, if we were shading that y-axis number line. All right. Well, I've messed my graph up, but there we have it. Okay, I just wanted, for this final little piece, just to show you one other strategy you could use with piecewise defined functions, and that would be to graph the entire line and then just erase away the parts you don't want. So like I'll just focus on the middle line, this blue line. I'm not sure if you recognize it, but this is actually in point slope form. I guess except it's got the plus there, but we can think of that as an x minus -2. So that tells us our x coordinate of a point we know on the graph is -2, and then the +1 is our y coordinate for that point. So we do know a point on the graph, and of course we know the slope is 1/3. So let me plot -2, 1, and that is a point that I'm going to want to actually have on the graph. And then we can just use our slope of positive 1/3, right, to go up 1 to the right 3, up 1 to the right 3, 1 right 3, and then of course that's also the same thing as -1/3, so we could go down 1 and to the left 3 to get points that way. And then we could just draw in, I'm going to use dashed lines so my eraser will work better here on the computer, but and we can just kind of draw in our line there, and now come back with our eraser and take away the parts we don't want. We only want, we only want our x values to start at -2. So let me get rid of all this here up until we get to -2. All right, and then we don't want anything beyond 1. So let's get rid of all this back here till we get down to 1, and I might even get rid of what's going on at 1. And now we can just make it, tidy it up here. We want this shaded part here, we want this to be unshaded at 1, and then we can draw our line in there. So there's a way that you could approach doing piecewise, is just graph the whole thing and then get rid of the part you don't want. Hope this helps. Well, we might talk about the last part, number 6 on here, but you don't need to worry about that for the homework.